Hello everyone, I hope that you are doing well. This video is about the passive evolution of the mobile generation, how they started and how they are improving. Because as we are going to get familiar with different technologies and to know how to simulate them in different platforms, the first step is to know the basic features and advantages and disadvantages of different mobile networks. It was around 1980s that the first generation of mobile or cellular networks appeared. At that time, it wasn't very powerful. It couldn't cover large areas. The quality of the sound was very low. It was just for basic calls. It was the first goal was to connect people, but not in very large areas. After around 10 years, the second generation of mobile technology appeared. It could improve a lot of aspects of the first generation. It could increase the quality of the connections. It could increase the mobile download speed, but as you can see, it was very low, and it could encrypt the calls, so you could at that time people could connect without worrying if someone is going to listen to them. Okay, and one of the uh, important aspects was adding SMS and MMS at that time. By these improvements, mobiles were used massively, and most of the people started to know about them and they wanted to use a mobile device. One of the most improvements was introducing 3G, the third generation of mobile networks. It was in the beginning of 2000, and it could bring using and surfing on the internet widely. At that time, people were experiencing using some video conferences, I don't know, video streaming, and some popular software such as Skype appeared to connect people around the world. So it could improve the downloading speed of the 2G, but it wasn't comparable to the generations that was supposed to come, such as 4G, 5G. At that time, they could, the researchers and the industrial people could improve the downloading speed to 2 megabit per second. After around 9-10 years, at the end of 2000, LTE or 4G network came to reality. It was a breakthrough in the using the internet, and it improved the quality of the web surfing, video streaming, downloading and uploading. They could improve the peak data rate to 1 gigabit per second, which was a massive number at that time. A peak data rate is a data rate that can be achieved in ideal situations. After peak data rate, we have user experience data rate. It is a data rate that people can experience in their daily lives. It was 1 megabit per second, which was a high number for a mobile generation at that time. People were using their mobile when they were walking, when they were on their cars, or they were on the train. Okay, and the interruption was very low. And more importantly, LTE could bring low latency that some latency sensitive applications such as, I don't know, gaming applications can benefit. It could increase the latency to 10 milliseconds, which was a great number at that time. Moreover, if you run a vehicle that is moving around 350 km per hour, you could keep your connectivity, which was a great improvement. LTE was improved to lead to LTE Advanced and then to LTE Advanced Pro. As they were moving forward, different qualities and different features of the network were improved. At the end of 2010s, another breakthrough in mobile generation, which is called 5G, came to reality. 5G is going to change daily lives and different aspects of human lives. First of all, it could improve both of peak data rate and user experience data rate to really big numbers. Uh, by using these numbers, people can experience really enjoyable internet surfing, downloading, and other activities. Moreover, by leaning on some new technologies such as edge computing, the latency was reduced to 1 millisecond, which was another improvement to the previous generations, and the mobility was improved to 500 kilometers per hour. Moreover, 5G could support dual connectivity properly. Dual connectivity means that when there are, for example, two antennas, one of them is supporting LTE, another one is supporting 5G, the device can connect both of them, so it can benefit when one of them fails. Both antennas can be 5G, or one of them can be 5G and the other one LTE. 5G brings new features by leaning on different use cases. Enhanced mobile broadband is one of the popular use cases that 5G has. It increases the downloading and uploading experiences. The main focus is on the data rate. After this one, massive machine type communication is for supporting a lot of, I mean millions of devices in small areas. It helps to support some other use cases such as using Internet of Things. As we know, smart cities are getting more popular. So, for example, we have smart traffic lights, we have smart parkometers, and a lot of smart devices inside the city. 5G can support all of them and make connectivity between them, so they can transmit data without any problems. Another use case is ultra reliable low latency communication, which is uh, which aims at reducing the latency to 1 millisecond. It is a really great number, and time-sensitive applications can benefit from it. Applications such as the ones that are used in vehicle to everything that we have in autonomous vehicles. Okay, they need to connect to a lot of things with low latency, so this use case can be beneficial. In conclusion, 5G improved all of the aspects that the previous generations had. Aspects such as the data downloading, data rate, uploading, latency, and more. If we compare all generations in one table, we can see the summary here. The year, the use cases really changed during the last 40 some years. And the important thing that we need to focus in this table is the frequency. As we can see, as the generations moved forward, the frequency increased. What is the benefit of increasing the frequency? When the frequency increases, the data rate, the bandwidth, so the data rate can be increased. Okay, but it has another flaw. As the frequency increases, the coverage area is going to be reduced, and the penetration power of the signal is going to be reduced. It cannot penetrate through different materials such as buildings, cars, buses, okay, blah blah blah. But okay, it is going to improve the average speed, which is another flaw. So we can have a trade-off between them. Because of that, small cells are being used in 5G networks. Because we can use them in a lot of places. We can put numerous small cells. Okay, 5G is moving toward using millimeter wave frequencies, which is above 25-30 gigahertz. Because of that, it can provide high data rate, but in contrast, lower penetration. Right now, the standardization organizations are working on 6G. They want to put the first steps, and they are going to establish a lot of rules, specifications that we can use 6G in the coming years, maybe in 2030 or sooner than that time. Okay, some of the main features of 6G is its high and massive peak data rate, which is going to be 1000 gigabit per second, and it is going to be 1 gigabit per second for user experience. That is something that we cannot believe right now, but it is going to be a reality in the near future. That is easing the way on using some new services such as holograms. The latency is going to be less than 1 millisecond. It is another massive improvement. And finally, the mobility is going to support 1000 km per hour, so you can easily use your device which is connected to 6G when you are in a high-speed train. Okay, I hope that we can use 6G very soon. This video was an introduction to different mobile generations. In the next videos, we will get familiar with other aspects and other technologies, and how to simulate, how to use them in our daily lives.